So it is Monday and we are taking our practice final. So this is going to be literally exactly what your final looks like, just with slightly different questions. So what I'm going to do is start by writing answer guide. Ooh, and the candy cane.
Get one at the door when you come in.
Really? I didn't even see that. I might have to go back and get one. Answer key. Okay, so let's start with number 1. This goes way, way back to the first unit, constructing an angle bisector. Do you remember anything about constructions? It's been a minute. So we're going to take our compasses out. And the first thing we want to do,
Be like smaller than half-life or something like that.
yes, we want to make it opened up about smaller than half of this, what's it called? This ray here on our angle. And do you remember where we put the pointy part of the compass first?
And the big dot.
Yes, on the big dot, the vertex. And we're going to start by making an arc that touches both, oops, I messed up a little bit, touches both edges of our angle. My goodness, my words today. Okay, so something like this. Perfect. So that's all right. Now, notice we've created 2 intersections. Do you remember where the pointy part goes next?
On those 2 intersections.
Yes, on the 2 intersections.
Make sure it's the same.
Yeah, we're going to keep our compass opened about the same. And we want to now make some arcs inside of our angle. So let's do that. Oh, here's what I've got. I've got a little wiggly X in the middle.
That's what's taken at the moment because mine is weird dot.
That's okay. All right, let's see. Beautiful, perfect. And I accidentally lied. We do need a ruler.
Wait.
So, do you remember what the last step is here?
Draw a line.
Yes.
To the little intersection.
Perfect. From the vertex to that intersection we created, we will draw a line. And this line is the angle bisector. Just a few little steps here. Not too bad. So whenever I'm grading your final, I want you to keep all your markings so I can see that you did it properly. So I will be looking for, this will be a little guide. You don't have to write it, but it could be helpful. I will be looking for first that arc. Next, I'll be looking for, after the arc, those 2 intersections inside of your angle like that. And then last but not least, I'm looking for the bisector going through that intersection. Now on the first quiz that we took, I was also grading you on if you marked that these angles are the same, but I'm going to be a little more lenient on this one. As long as I see these 3 markings, you got it right. All right, you feel good about that one? Perfect. So now let's look at number 2. Another thing we haven't done in a while. One thing that we should do on this picture first that I forgot to do is mark that these 2 lines are parallel to each other. So because these 2 lines are parallel, we know that certain angles are going to be equal to each other, right?
Like the 78 degrees and the 2x plus 4.
Exactly. Exactly. So it says we need to find the value of x and then solve for all missing angles. So number 2 is finding x. Number 3 is the angles. So how would we solve for x?
First you do 2x plus 4 equals equals 78.
Perfect. 2x plus 4 equals 78.
I always have to put X on.
Yes.
So it's X.
Yes.
Something equals X.
Perfect. So what do I do here first?
Minus the 4 on this side.
Good. Minus 4. And that gives us,
2x equals 74.
good, 2x equals 74. And one last step.
Divide by 2,
Perfect. Divide by 2.
which makes X equal,
Let's see. Yep, calculator time.
here that way. 37.
37. Perfect. So x is 37. Perfect, perfect. Okay, so now how are we going to find all of these missing angles?
First, doesn't C equals 78 as well?
It does. It does. So these are vertical angles, the ones that are right across from each other. So any of these with one arc will be 78 degrees. So C is 78 degrees. Is there any other angles that are the same measure as C?
E would be
Yes, E is also 78 degrees. E would be a corresponding angle. 78.
those would be the only ones that are 78 degrees because those are the only ones that are one arc. The rest are
Perfect.
2 arcs.
Perfect.
In order to find that one, wouldn't you have to do like 78 plus X equals 180?
Yes, perfect. So how did you know that we were going to add them and set them equal to 180?
Because in order to simplify, just go based off of a single line.
Yes, perfect. So these missing angles now, if you were to put them together with any of the angles we know, we're going to get a straight line. So a straight line is 180 degrees. So what equation are you setting up here?
X plus 78 equals 180,
Perfect.
which makes it only a one-step curvature.
That's right. So we'll just subtract 78.
Makes 102.
Perfect. 102 degrees. So which angles are going to be 102 degrees?
The rest of them.
All the rest. Perfect. So angle A, angle B, those are 102. Angle D and angle F, all 102.
And that one's finished.
Perfect. Okay, so there is that. Let's go to the next page. Okay, so number 4, we are finding midpoint.
That's a formula.
It is a formula. It's been a while since we've used that. Do you remember the midpoint formula?
No, it had something to do with X1 and X2.
Yes, it does. So all we're really doing is finding the average X value and the average Y value. So let's write out the formula because I think I remember it too. I'm going to say midpoint equals, and I believe we do, I'm going to use colors here, red and blue for X and Y. We have x2 minus x1 divided by, oh no, it's plus, my bad, x2 plus x1, or you could do x1 plus x2, either one will work, divided by 2.
If I can get 10 on
And then the same thing with y. y2 and y1 divided by 2. And our midpoint is going to be a coordinate. We'll have an x value and a y value.
Wow, almost a whole lot of people don't even
So once you have your formula written down, what do you think we should do first? Yes, yes, you're reading my mind. We always, especially if we're not sure where to start, the best thing to do is to start by labeling what you have. So what comes first, x or y? X. So I've got x1, x2, and I got y1, y2. Okay, so once they're all labeled, what am I going to do with all those numbers?
Plug them in.
Yes, ma'am, we're going to plug them in. So let's see, what numbers am I writing in first?
12 and 2 would be, we're doing the x2 plus x1, it would be 2 plus 12.
Perfect. 2 plus 12 divided by 2 for my x's. And how about my y's?
It would be 3 minus 8, though.
Yes, 3 plus negative 8 is the same thing as 3 minus 8. By 2. Okay. So now let's simplify. I know 2 plus 12 is 14. And 3 minus 8 is negative 5.
You got both of my apps.
Ah, is it messing up on you?
Yes. There's 2 of them
Oh.
over here, but this one might be further.
I know the ones that are, that have the wheel inside, I feel like they get so messed up.
Well, I kind of fixed it, kind of, but it's getting off of its line where it
Hmm.
needs to be.
All right, where are you in your work now?
Just simple.
Simplifying, okay, so have you simplified your x value yet?
Nope, that's the stuff I'm doing, simplifying s and s.
Perfect. So here's as far as I got. I knew 2 plus 12 was 14, and then I got to divide 14 by 2. 14.
Divided by 2 is 7, I believe, because 7 plus 7 is 14.
Yes, perfect. So our x value is 7.
Honestly, I don't offer them to, but they're the 14 and negative 5, so I'm just simplifying it all together.
Smart. So all I did instead of doing it all together is I just simplified the top part and then I did the bottom. So like 2 plus 12 was 14, and then 3 plus negative 8, or 3 minus 8, I got negative 5.
Negative 5 divided by 2, that would be negative 2.5.
Yes, perfect. Negative 2.5.
I'm double checking it, but I believe that's what it is.
It is correct. So
Yep.
that should be our answer. 7, negative 2.5. So we'll write that in the blank I left you. Perfect.
It's always good to double check.
Yes. All right. Let's look at number 5. So now we're using, yes, another formula. But guess what? So I didn't tell you this whenever I originally taught you the distance formula, but the distance formula, let me show you, it's like rise over run, but it's also another version of the Pythagorean theorem where we do a squared plus b squared is c squared, because we're really just finding that missing side of the triangle. If we know how long a and b are, we can find c. So let's remind ourselves what the distance formula is. Let me see if I can remember it off the top of my head. I know. I might have to pull my notes out. I feel like it was something with a big square root. It was like x1 minus x, or x2 minus x1 squared plus y2 minus y1 squared, and the square root of that.
I believe it is that.
I think it is. I'm going to double check because I don't want to tell you wrong. But it's going to come out to be the same thing as finding the missing side of a right triangle. I'm going to pause that real quick. All right, so our distance formula, I'm going to write it down here where I'm not using up as much space. So,
That would be because the rest of this little section.
yes.
Is, that's what we're going to do as well.
Right. So the distance is the square root of x. I'm going to use colors. Red, x is x2 minus x1 squared plus y2 minus y1 squared.
This one has to be x2 to x1, y2 to y1 because it's a chart.
Yes. Now, if you don't want to have to, like if you want to skip a step and save yourself some time and not have to do the x2 minus x1 and y2 minus y1, all we're doing is finding these numbers. Like here's going to be our x2 minus x1. It should come out to 1, 2, 3. And our y2 minus y1 should come out to 1, 2, 3, 4, 5, 6. Now we can use the formula and double check, but if it works, then you do know in the future you don't have to use the formula. You could just do Pythagorean theorem and just count your sides. All right.
It's gonna come out to 30 if you just do the x.
Yeah, here, I haven't labeled my...
4 minus 1 is 30.
Yeah, 4 minus 1 is 3, and then 5 plus 1 is 6. So it will work. I'll still write it out just in case. So we have d equals the square.
But we don't know how to do this square root of things because the radical cancels those out.
So what we're doing by writing the big square root is because really what we're solving for is x2 minus x1 is our a, y2 minus y1 is our b, so a squared plus b squared, and we're solving for c. But instead of writing c squared, we just went ahead and put the square root over here. Does that make sense? Okay, perfect. So like here's our c. So let's see, I'm going to rewrite what you just told me. 4 minus 1 is 3. 5 minus negative 1 turns into 5 plus 1. That's 6. So I have 3 squared and 6 squared. Okay, and what's 3 squared? Yes, 3 times 3 is 9. Plus, now we need 6 squared, or 6 times 6. Hmm.
Just 6 squares in the calculator. 36.
36. Perfect. And
That is way too big just for me to do in my brain.
that's okay. Let's see. So now we need to add these. 9 plus 36. I got 45. Perfect. And then we have one last thing to do.
And we're just going to square root of something with the little
Yes, so we need to do the square root of 45. So second square root 45.
I'm just doing all that intro stuff.
Yes.
Which gives you 6.7082033932.
Perfect.
It'd be better to just put a 6.71.
Perfect. Yep, I like to keep about 2 decimal points, so we'll make that 6.71. And there's no measurements, so we'll just say units. 6.71 units. And that is our distance. Perfect. Okay, we have officially completed our Unit 1 part of the final. Now we're on to Unit 2, which is triangles. So, we're looking at side lengths in the next question.
If it's a triangle, doesn't that mean it equals up to 180?
Yes, the angles will add up to 180
I was just
degrees.
saying yes or no for that. So we just gotta add them all up and see if they equal.
So that was with our angles, but these are side lengths.
So
So,
what if they're equal, like equal or more than the number?
let me think. Can you
Because
read?
there's the biggest number, and then we're supposed to add the 2 smaller numbers.
Yes. Yes. So we
Are they
have,
supposed to be over the?
yes, if they're bigger than the biggest side, when I add my 2 smaller sides, then it is a triangle. If it's not big enough to be the same, or if it is smaller than or equal to, then it's not a triangle. It has to be bigger.
First, this number 6 would be a triangle because the 23 plus 21 is 44.
Yes, 44. So here's a good way that we could show work. I like to circle my biggest side, and then I just add together my remaining sides. And if when I add them together it gets a bigger number than what I circled, our answer would be yes. It is a triangle.
Now, the biggest is in the middle. I have to rewrite that.
Yes. So for number 7, yeah, 38 is our biggest.
That's not going to be a triangle because 5 plus 12 is that.
No, not even close. 12 plus 5 is only 17. So 17 is much smaller than 38. So is it a triangle? Nope. It is not. All right, show that again for
Oh,
me.
this is the difference part of the 90, 45, 45. And
Yes.
the 30, 60, 90.
Yes, so this is the special triangles where we're using like x, 2x, x radical 3, x radical 2. So we got to remember back to that.
So,
Do you remember, let's start with the 45, 45, 90.
45 would be x and x.
Yes, so we have an x here and an x here, which means these sides are the same length.
What would that be?
Either x radical 2 or x radical 3. I always forget. So let me be
And then I know
doubly
the
sure.
FTE is just plain x, that being the smallest.
Yes. Let me pull up my notes and be 100% sure I tell you correctly.
I know when I take the actual final, I'm just gonna bring in all the tests I have because
Right.
I do most of it.
Okay, so here's what it is. It's x radical 2 for the 45, 45, 90. So x radical 2. And then our 30, 60, 90.
And then the D and F is just x radical 3.
Yeah,
And then the
D to F.
hypotenuse of that one is just x.
The
2x.
2x, yes. 2x.
First, I was trying to do
X.
x to the second power.
Right, right,
And
x
it's just
squared.
Like, no.
Almost.
Try to put the 2 in a different spot.
I know it.
Okay, let me put these up. Let's see.
Okay, so let's look at number 8. I know that from B to C, I have 18 inches. So,
That's the plane of x.
yeah, so
That means
x is
A to
18.
C is 18 inches too.
Perfect. So AC must also be 18 inches.
And then you find AB, you just put it in the calculator as 18 radical.
Perfect. So we already know what x is, so we can plug that in. 18 radical 2.
That is, honestly, might as well just put it as 25.46 because it gives you a whole lot.
Right.
Remember?
So 25.46 inches if we round. 25.46 inches. Perfect.
I know you don't really care if it's the exact point as long as it's around that area.
Yes. So if you wanted it to be the most exact possible answer, you would actually leave it with the radical inside. Since this is what we call an irrational number, that radical 2, those decimals are going to go on forever and never end. So by rounding it, our answer is actually less accurate. So to be the most precise, you just leave the radical 2 on there.
And I like turning it.
I know, I like the decimals too because they make more sense to me.
Okay, FD is the x radical 3.
Yes.
And then that has given us the answer of 31.
Perfect.
Uh,
So what do we need to solve for here?
First we need to solve for x.
Yes, we do. So I know that x times radical 3 is 31. So how would I solve?
Seems like an equal to each other.
Yes.
How would we put it in formula? So here we do x.
Hmm.
Wouldn't we have to take away the radical?
We would have to get rid of the radical 3. Do you remember what operation we're using here though?
That's like multiplication.
Yes. So we're multiplying.
Divide by radical
Yes, so we divide. Divide by radical 3 on both sides. That'll get rid of it.
And then you put it in the calculator.
Yes.
No way you can do that.
No, not in our head. So we'll do 31 divided by radical 3.
Which gives you another decimal.
Another decimal.
So, honestly, we might as well just do this as 17.90 because if you look at it,
Yeah, it would round up to 90. So a lot of times, and this is optional, whenever we have a number like this where it rounds up to 0.90, I usually just keep 3 decimal points to make it a little more accurate. However, if you put 17.90, you'll get it right still. I won't count you off for that. But I'm going to keep 3 decimal points here since we still have one more side to solve. So 17.
we could get a 17.898.
Perfect. 17.898 inches. So that's our x. And we just solved for x. Are any of my sides solved?
Yeah.
Yes. E to F is also x.
To
17.898.
find DE, you just have to do 2 times for x.
Perfect. So from D to E, it's just that number times 2. So 2 times 17.898. So I think I'm just going to take this answer times 2.
Honestly, I'm just rounding it because it'll get us around the same.
Right, it will. What did you get for your answer?
I have to find out. I got 35.796.
Perfect. So what could we...
Definitely the same answer you would have got if you rounded.
Right, pretty much exact.
Here, it does it for you.
Right. So 35 point, we could do 3 decimals or we could do 2. We could do 796 or
80.
or 0.80.
All 3 decimals.
Perfect. I think I'm going to keep it as 796. Just since I did that on the other one.
Yeah, also, I might as well do that because it gives it to you already.
Right. Perfect. Okay. So I think you've got those down. That's good. So let's look at number 10. Now we're doing the Pythagorean theorem. What is the Pythagorean theorem?
Isn't that a squared plus b squared equals c squared?
Yes, it is. So let's write that. A squared plus b squared equals c squared.
I'm writing mine down on a little section by where you have the page number at.
Yes.
Because I don't have a little opening right here.
You did your work a little lower than me. I got ya.
I do it in a different section, but it still works out.
Yes.
Not plus equal. I don't know why, but my hands trying to do something.
Oh, that's all right.
But,
So
we
once
have B and we have C.
we
We
do.
need to solve for it. So this
Right.
would be a squared plus 8 squared equals 12 squared.
Perfect. A squared plus 8 squared equals 12 squared.
Then first you have to find them square
Yes.
because you can't solve for it.
So 8 squared is perfect. I think 144.
Yep, 144.
Awesome. 144.
And then we subtract the 64 on both sides.
Yes. 64.
Honestly, I think this is a 3-step question because then you have to find the A.
Yeah, it really is. This is a lot of steps.
Honestly, that's bad. That's what it could be.
Right. Could be worse. Always could be worse.
And
Okay.
then just due to this using calculator we can just plug things in.
Right. That makes it so nice having the nice calculators.
Yep.
So let's see. 144
Which
minus
makes it, the
60.
A squared equals 80, but you have to use radical sign.
Yes.
Turn it into A, not A squared.
Yes. So we
And
have a
opposite of,
squared.
The 2
Are squared.
or little squares, then it would be radicals out.
Perfect. So yes, opposite of squared is the square root. So those cancel, leaving us with A equals, let's see.
8.95.
Perfect. Ooh, would it be 9.5?
Nope, not 4.
9.4. It's super close to 9.5 though. 8.94. And what would our units be? Inches. Perfect. 8.94 inches. Perfect. All right. Next page.
This has a whole lot of pages of
I know. Well, the final is a little bigger than the normal quizzes, and here's how many there are. It looks like there's 16 questions total and a bonus.
Which makes 17 total for you.
17 if you do the bonus, you're right. Okay, so now we are to Unit 3, quadrilaterals and polygons. So how do we find the area of a quadrilateral?
Area is, isn't that like base times height?
Yes, it is. Base times height. So I'm going to write that up here at the top, I guess. I think that's where I'll have most room. Area is base times height.
And then perimeter would be, add up all sides.
Yeah, just add up all the sides. There is a formula for perimeter, but I find that the formula is not very helpful. I feel like it makes more sense just to see all the sides and add them together. So I'm just gonna write add up all sides.
But it's easier that way.
Right.
Because when it's, if they're all equal, just do like 55 times 4.
Right, exactly. So you're already on the first step here on number 11. You said we could do 55 times 4 to find the perimeter. Let's do that. So perimeter equals 55 times 4, because all 4 sides are the same length. So let's see what that gives us.
That would do 220.
Perfect. 220. What's our units?
Inches.
Inches. Good.
And then area would be, wouldn't that be 55 times 48?
Yes, area is our base times our height. Our base is 55.
And then like a rhombus or a parallelogram, it's that has little dotted lines your height to do so that
Yes.
the angle.
Right, exactly. So our height is 48, our base is 55. We'll multiply those. And we're going to get a great big number.
That would give us 2640
Perfect. And what would our units be?
inches squared.
Inches squared. Good. Now, what type of quadrilateral is this?
Wouldn't this be like rhombus?
Yes, it is a rhombus.
I remember, I don't remember how to spell it, but
That's
I remember
okay.
what they are.
Here, so it's RHOMBUS. It's just a parallelogram with 4 sides that are the same length. It's like our tilted square.
Yep. The next one would be a rectangle.
Yes, it would be a rectangle. We'll go ahead and put that in. Sometimes I think it helps to identify the type first,
That's what I
honestly.
normally do when you gave us a whole bunch of problems
Yeah.
where you had to find type. I did the type first and then I went to the others because that's the easiest to find.
Honestly, especially with the polygons, like whenever we have a bunch of sides, I think it makes it so much easier to figure out how many sides you have first.
It's easier to find the number of sides but not remember the name.
Yes, well, that's why we have our our little cheat sheet with all the names on it, which I'm happy to make copies of.
Yeah, I have it in the binder. I just
Perfect. And honestly, whenever we get to the 13 and 14, I'm going to have us make like a little sticky note with a guide of all of the names from 3 to 12, just in case I throw you a curveball on the final. That way you have all the names.
Then you realize, why do they have to create so many names instead of after 8 of them just do this number going?
Well-
like what they do after.
Right. That's what I don't get. Honestly, it should just be like 3 gone, 4 gone, 5 gone, 6 gone. That would make the
So
world
much
easier. Okay, so how do we find area or perimeter? I don't care which one you want to do first.
First area would be
Yes.
82
Mhm.
times 31.5.
Perfect. 82 times 31.5, our base times height.
Honestly, what got me to freeze up was trying to put them in the exact order they're supposed to be.
Oh, so luckily with multiplication, you could do it in either order and you'll get the same answer.
Yeah.
Another pretty big number for that area.
And it seems to be pretty big.
I know,
And
especially with these big numbers.
Into it because every problem you're giving us, area is bigger than perimeter.
Yes.
Well, apparently, perimeter can be bigger than area.
I know, we'll have to, if there's time today, we'll have to do out that problem where the area is smaller.
Because
Okay.
I had the question of how come it's always bigger? Then we found out, oh, it's not always
It's
bigger.
not.
It's just like, what?
So I got 2,583. Is that what you got?
Yep,
Perfect. And our units?
inches squared.
Beautiful. Okay, now perimeter. And how do you find perimeter? What's like your method?
Normally when it's like this, they don't all equal the same thing. I do like the height, like adding to each other. Like
Yeah.
31.5 plus 31.5, then I do like 82 plus 82.
Right, so you're just adding them all together. So we could do that, 82 plus 82 plus 31.5 plus 31.5. We could also do 2 times each number. I'll do,
That's probably going to be the same because it takes like less space.
right. So let's do 2 times 82 plus 2 times 31.5. I should have gave myself more space for perimeter.
Well, this doesn't have a whole bunch of space to begin with.
I know it.
That's why normally these things we have extra paper with us.
Right. Okay, so I
That
got
would-
164 for 82 times 2.
Because when I normally add those and then I take the big number that you add up in.
Right, that's smart too. And then 63.
Because either way we have to type that same amount.
Right. Okay, so now we gotta add these two.
That's the least part. Because you can just do into to get the answer.
Right.
That's why I like this calculator so much.
I know, it's nice to be able to see what you've typed in.
And then you can just go up and get,
Exactly.
then put your symbol and do it again.
Okay.
What I got was 227.
Perfect. That's exactly what I got. 227 inches. Perfect, perfect. All right. So here's where we're going to make a little sticky note of all the different names of polygons, just in case I ask you for them. So, I think we know that a 3-sided is a triangle. And I just told you in the question above, 4-sided is quadrilateral. So, are we good to start with 5 sides?
Yeah.
Okay, so 5 sides. Remember what that's called?
Honestly, I'm just going to put the number then.
Smart. Save some space.
Like, put names and sides. But,
Smart.
Like, what you tell us to do on the test, so.
Right.
Like, if we put the wrong name, you'll know if we actually know what we're talking about.
Exactly. So a 5-sided polygon is a pentagon.
And then,
How about 6 sides?
that would be.
It's okay if you don't remember them. We haven't done much with them. We really just looked at them for a moment.
I remember the side numbers and what we're supposed to do.
Yes.
That, but I don't remember the names.
So 6 sides is a hexagon.
You put a hex on something.
Yes, hex. And I also remember 6 also has that X sound. 7 sides, similar to hexagon, but it's heptagon. Heptagon. Now the 8 sides is one that most people know because it's like a stop sign. Yes, octagon. O-C-T. Right, right. Octagon. And something that also helps us remember, 8 sides. Yes, octopus. 8 arms or 8 tentacles. Okay, 9 sides. Right. So 9 sides is a nonagon. Ten sides is a deck. D-E-C-A, decagon.
Starts with a D as well.
Yes, a decade. A decade. That is 10 years. Perfect.
So it really makes the same things because it's deck there. And it's
Right, right. So these are all, I forget what the origin is, but these are different prefixes that mean the numbers, which is why we use them. So 11 sides. Honestly, I'm forgetting 11 right now. What is 11 sides called? I might have to skip back and come back to it because I do remember 12 sides. That's our dodecagon. Dodecagon. All right, 11 sides. What is that? Let's see. 11 sides. What are you called? I don't think I asked you for an 11-sided shape, but it would still be nice to know. I'm gonna look it up on Google because I don't know where that paper is. 11.
I know where my paper is, I just don't have it.
Inside polygon. Ah, hendecagon. So strange. Hendecagon. H-E-N. Decagon. Hendecagon. There we go. Now we know. Okay, so there's our little cheat sheet for the different names for how we label the types of polygons. And for number 13 and 14, we are going to be finding area and perimeter. And I see you're still writing those down, so I'll pause. I'll take your time with that.
I had to do Friday.
I gotcha.
Makes it easier.
Oh,
Sorry.
there it goes.
It goes, but it was stuck to my finger.
Okay, so here, before we go into solving these, I'm going to put this sticky note to the side. Let's get the area and perimeter formulas written down for these. So, whenever we're working with polygons that have different numbers of sides, we always let n equal number of sides. And then go ahead, Ella, what were you going to say?
Like, I think the area is like 20. Like for this one, be 28 times 36. Because I know this little tiny halfway line has a name to it. I just can't remember what it is. It starts with the A, I think.
Apothem. Yes, it's the apothem. So you're super close. Super, super close. we're gonna do area equals 1/2 times,
Oh, it's perimeter.
yes, times perimeter.
So, and this one we have to find perimeter first.
We do, times apothem.
Right now, it's 1.
And then, do you remember how to find perimeter? There is a good formula for these other than just saying add up all the sides.
It's the number times the number of sides.
Yeah, exactly. So it's going to be that side length times n, or the number of sides. So let's see. I'll write side length times n. Okay, so these we're going to have to kind of work backwards. We'll do the type, the perimeter, and then the area. So what type is number 13?
That's a pentagon.
Pentagon. We have 5 sides. Pentagon, in parentheses, I'll write 5. So how would we find the perimeter?
You do 28 times 5.
Perfect. So perimeter is 28 times 5. And I got 140. Did you get the same thing? Oh, sorry, I'm going too quick.
Very good. I've always worked slowly.
Oh, that is okay.
So, that would be.
Perfect.
That would just be plain inches.
Yes.
Then for area, that would be 1/2 times 140
1/2 times 140 times,
36.
good, times 36.
And that would equal, you can really just put this all into.
Right, we could do 140.
It seems to get a fraction in this.
Oh, yes.
Alpha
Alpha y equals,
enter.
yes, yes. It doesn't work on this calculator for me. Let me get my calculator that works.
Honestly, I think that a couple of them are just programmed in differently.
No, I think so too. So
That's
here.
why I stick to a certain number.
Yes, the special numbers. I need to mark that number 2 doesn't work. So alpha y equals, enter. Then I can type 1
I've started
half.
using number 20 because it doesn't have someone in your second, third.
Well,
grade class.
perfect. Then it's
So
just yours.
Yep. It's kind of, I prefer to keep things in certain
Right.
order because if you end up needing it for something, you'll know that that one actually works.
Exactly. So I'm going to type it in like that. 1/2 times 140 times 36.
Which makes 2,500.
Perfect. 2,520
Inches squared.
inches squared. Beautiful. And another way, if we forget how to find or how to type a fraction in, do you remember the other way that we could find this? It's basically the same thing. It's just,
As 1 divided by 2.
yeah. You could type in 1 divided by 2. You could also do 140 times 36
Divided by 2.
divided by 2. Perfect. Both of those will work just fine. You'll get the same thing. Okay, now the next one, I'm going to let you do this one by yourself. And I'll pause the video, check back in, and you tell me how you got your answers. And then I'll let you tell me the rest. Perfect. Okay, so when we have a shape that has a bunch of sides like this, I had a lot of students that put the wrong number of sides. So it might seem silly, but I think it's really helpful to mark as you count.
Disgusting. I
Oh,
have
no.
syrup in my hair.
Oh no!
I have French toast sticks for
Ooh, well, French toast sticks are good. So here, let's count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 sides. We have a decagon. Decagon. 10. Oh, I hate that feeling. So, how'd you find the perimeter?
Shower at Dad's house because our tub's broken, which causes to where we don't have hot water.
Oh, that is the worst. Okay, how'd you find perimeter?
I did 12 times 10.
Perfect.
The sides are 12 inches.
Yes, and there's 10 of them, so 12 times 10, and you told me that it was 120. 120 inches. So how'd you find area?
I did 1/2 times 120 times 23.
23.5. Perfect. So 1/2 times perimeter times apophthegm. So let's type that in. Alpha y equals, there's our fraction, enter. 1/2 times 120 times 23.5. I got 1,410.
Yep.
Perfect. Inches squared. Beautiful. We're almost done. Almost there. Okay, last page. Whew!
We only have 2 more questions that we have to finish.
Yes. And we got plenty of time. We still got like 10 minutes. So, now we're doing area and circumference of circles. So, let's write down our formulas first.
Circumference is perimeter technically for
Yeah,
a circle.
exactly.
Area is just area.
Perfect.
Diameter is the full line across, radius is the half line. We have
Yes.
the radius.
So that's a good thing to remember. Our diameter is the one that goes all the way across. And something I told my 4th period.
Our radius, all we have to do is do that times 2.
Yes.
The other diameter to find radius, you just do that divided by 2.
Exactly. Something I was telling my 4th period is that if you ever forget which one's diameter, when you draw the line across, it makes a D right here, D for diameter. So diameter goes all the way across. And radius is the smaller. So we have a radius that's 21 inches. And you said to find diameter, we just take it times 2, right?
Yep.
So 21 times 2, which is,
That is 42.
good, 42 inches. So how do we find the area? We have a formula for that. If you forget, it's up on that poster to the right side of the room.
That's 5 times 42.
Yes. So area is pi times radius squared.
Which also means we have to find the radius.
Yes, exactly. Luckily, we already have the radius here.
And then there's 2 different circumferences.
Yes,
Formulas we can use to find the same one.
absolutely. Let's find our area first. So we're going to do pi times what? 21 to the tiny 2
That's
squared.
because I can't hold it.
That's okay.
It is a
So,
92.
luckily we can type this all in one go as well. We have a pi button. Where is our pi button? Oh, it's right here. So second pi 21 squared. And we don't even have to type the multiplication symbols. Enter.
As long as we just have
big old number. Yes, you totally can do the multiplication symbols. Sometimes that makes me feel like a little better.
Do the little parentheses.
Right. Okay, so what did you get for area?
1,385.44.
Perfect. That's what I got. 1,385.44. What's our units?
Inches squared.
Inches squared.
Thing about area, it's always the unit squared.
Yes, exactly. And then how do we...
Not units. Wouldn't that be unit squared?
Yeah, we would just put units squared. So how do we find circumference? I'm going to write that formula at the top as well.
Since we have the radius in this, it would be, I know on that it says circumference is pi times diameter, but if it's
Yes. Pi times diameter. Or we could do circumference equals
that kind of the same problem for area. Kind of.
super similar. So instead of pi r squared, the squared is going to be a big 2. So it'll be radius times 2 times pi. Same thing as pi times diameter, which normally we write it as 2 pi r, just so that we don't accidentally make our 2 too small and square it.
That's reasonable.
Right. But since we have diameter, we solved for it, we could just do pi times diameter.
Yeah, it'd be.
Either one will get us the same. So let's see, circumference equals,
It'd be easy though, because it means you have to do this.
right,
So,
pi times 42.
pi times 42.
Mm-hmm. And let's see, pi 42.
That equals 131.95.
Perfect, 131.95 inches.
Now for this one, we have to find radius.
Yes, we do.
So, in order to find the radius, you just do diameter divided by 2.
Perfect. So radius equals 45 divided by 2. So our diameter's given. I'll fill that in, 45 inches. And what did you get for the radius?
22.5.
Perfect, 22.5.
Now to find radius of pi times 22.5 squared.
Perfect, pi 22.5 squared.
Big number.
Yes, very large. What number did you get?
I got 1,590.43
Perfect, that's what I got. And our units?
inches squared.
Inches squared. And last but not least, circumference. We're doing pi times diameter. So pi times 45. And once you solve that, let me know what number you get.
That's
Perfect. 141.37. That's our circumference. Inches. Okay. Finally, last thing, our bonus point opportunity. This is totally optional, but if you got time, I say we attempt it. So, I want you to find the total area and perimeter of this combined shape down here. And the shape is made up of a square and two congruent right triangles that are attached to the square. Yes, it could make a rectangle if I took this triangle and stuck it right over there. Totally would. It would make a perfect rectangle. So you could do it that way. You could do it in a lot of different ways.
What area isn't that base times height?
It is base times height for a quadrilateral.
What would it be for this one?
So whenever we have a shape like this, there's a few things we could do. We could do exactly what you said, where we kind of remove this triangle and put it back over here so that we have a rectangle, which we know how to find. Or we could find the area of each part and add them together.
Honestly, I like to just do it as a rectangle.
Let's do it.
Less stuff to do.
Let's do it. So let's X out this triangle and put it over here.
It's not perfect, darling, but
That's all right. Mine's not either.
doing that. That would mean first we'd have to. We know that these little single lines are 25.
Yes.
But in order to find base, we have to add 2.
Yeah. So we've got 2 of those lines for our base. So 25 times 2 is what?
If we do that right here, that would be 50.
50. Perfect. So 50 inches. This will give us our area. So how do we find our area here?
We just do 50 times 25.
Perfect. 50 times 25, base times height. So let's see.
That'd be 1,250.
Perfect. 1,250 inches squared. Now the perimeter is a little trickier because we want to know the perimeter of the original shape. So we know all the side lengths for, let's see, I'm going to put in green what we know. We know this outside length is 25. We know this is 25. We know this is 25. We know this is 25. But we don't know the lengths of these orange sides. What could we do to find those missing side lengths? There's a couple ways we could do this. You stumped? Okay, so let me show you the 2 ways.
One of these.
That's okay, we haven't done these together. That's why it's a bonus. So what we have here is 2 triangles that are the same. So if I solve for one side, I know that I can solve for the other. It means that they're the same. But let's notice what's happening with these triangles. I'm going to pull one of them out.
Oh, is that one like a 45, 45, 90?
Yes, it is. So with a 45, 45, 90,
What we did, which is 45, 45, 90. We just gotta do 25 radical 2.
yes, yes. So our sides here are x, and this one is x radical, what is it, radical 2 or 3? Let's look. Radical 2. Okay, I trust you. You're right. Right here. So that means this is x radical 2. So if x is 25, then this must be 25 radical 2. So let's see what that gives us. 25 radical 2.
That does 35.36.
Perfect. 35.36. And now we need perimeter. And how do we sort of define perimeter? How do we know which sides to use?
What is the perimeter?
So we don't really have a specific formula here, but if I ask for the perimeter, yeah, you're really just adding them all up. But do I include my sides that are on the inside? No, perimeter is just the outside. So, let's see.
We had 4 of those 25.
Yes, so we could do 4 times 25 since there's 4 of those. And we can add it with, looks like we have
2 of the 35.36.
good 2 of the 35.36. So then we just multiply those and add them together. So let's see, 4 times 25 gives us 100. Give us 1 second. That's okay. 100. And then 2 times 35.36. Perfect.
100 plus 70.72.
Uh-huh.
And that equals 170.72.
Perfect. So that would be our perimeter. 170.72 inches. Beautiful. All right. That is the practice final. And we only went over by 2 minutes. Oh, okay, so
It only happened that way because we have that drill.
I know, that weather drill.
Had the drill really stuck to what we needed.
Right. So the practice final needs to be shown to me before you take the final. Now, since you're here, you already have your credit for it and you're all good.
Went over it.
Since we just did it. Yes, but anyone watching the video, fill it out, show it to me before you take the final. You'll get your full credit, and that is all.